Hey y'all, it's Steve, Hobo with Wood Chips. In this video, I'm going to show you what you need to do to set up an end mill or a bit in Millmage. Stay tuned. Alright, if you're brand new to CNC, raise your hand. There is a lot of information that you need to know about your end mill, your bit, your carving bit. How fast does it need to spin? How deep can you go? How fast can you go? These are things that are called feed rate, speed rate, chip load. There's a bunch of information that you're going to need to learn, and we're going to go over all of that as I set up one of the bits in Millmage. I just got my first order in from IDC Woodcraft, and IDC Woodcraft has all the information for their bits on their website for when you place that order. And if you're using any of the other softwares out there, they even have some databases that you can download and import into your software. Well, at this time, Millmage is brand new, and speaking with everybody's favorite Aussie, Chris, he has used a conversion tool of some type to do some type of conversion for the information that is out there for IDC Woodcraft. He was kind enough to share that with me, but there were a lot of things about it that I didn't like, and I wanted to correct some things. And then plus, it was everything. It was everything that IDC had to offer. So there was a ton of bit information, and I don't have that. And it was actually more work to go in and find the bit that I have than it was just to set up my bits as I go. And really, I think that that's the best thing to do. It'll help you get a better understanding of what your bit is designed to do, how it does what it does, when it does what it does. And Millmage has a real good tool in the tool setup that will help you to see and visualize the actual bit, and you can begin to conceptualize what's happening with this information that you're inputting into the software. You're telling it, I want a 40% step over, and this is, well, what? Well, you can see this, and we'll go over all that here. So let's jump into Millmage. I have actually deleted everything that I have, so I have no tools set up. So this would be going from scratch. And we'll walk through what I'm going to do. Is I'm going to do a split screen, and then if you're not familiar with how to do that, I'll show you how to do that here in this video as well. But I'm going to have Millmage open on half of my screen, and then the other half will be the IDC Woodcraft website with all of the bit information on it. So I can then take what I know from the Woodcraft website and input it into my tool library and know that it'll be exactly precise. Now, I have decided to set mine up with millimeters per minute with my Millmage instead of inches per minute. And everything that I see right now and I'm still learning, everything I see right now in the IDC Woodcraft page for the bits that I bought, it's all in imperial. It's all in inches per minute. There may be another chart out there that's metric. I'm sure that there is. I don't see it right now, and it doesn't matter. We don't need that because Millmage will do that conversion for us to a certain degree. So let's go set up an end mill in Millmage. So I've got Millmage open. And if I come over here to my Edit Tools button, you can see I have no libraries and no tool information. So I need to set up something. But before I do, I'm going to go ahead and set up my split screen. And to do that, if I just drag that down to where now, it's not docked in its home position, and then I take this and I drag it over and off the right side of the screen until, there we go. Once that gray area populates half of the screen, that's telling me it's going to populate that half. If I took it down you can get partial screens, but I want it to be half right there. Then it's going to show me what my options are. Well, here is my IDC Woodcraft that I have open. This is the streaming or recording information, and then I've got a version of Lightburn open. Well, I want this screen right here, so I'm going to click on it. And now that's going to give me the IDC Woodcraft website. And if I go back up here to shop by type, shop by sets, this is the set that I purchased. I purchased this 10-piece CNC bit starter kit for the 1/8" shank. So if I click on that, then come down to here, specs and settings, here is all the specs and settings for that. And then here's, like I said, databases for Vectric, Fusion, Carbide, Create. I don't know what that one is. Carvio. Oh, there's a Carvco. I don't know what, or I thought there is. But then for CNCs with routers, use this. But we have a spindle with the Cubiko. Thank you. The Cubiko has a spindle. Now, the Cubiko that I have, and one of the Cubicos that I'm going to be giving away, has got a 20,000 RPM spindle. The stock Cubiko only has a 10,000 RPM spindle. And it's important that you know what your max spindle speed is, because that's going to be crucial when you go to set up your tools. You're going to need to set up your RPMs for your spindle speed. And a lot of these tools, some of them actually call for in excess of 20,000 RPMs. I can't do that. So I've got to calculate what I can do with the 20,000 RPMs. And we're going to go over that too. But if you've got a stock Cubiko, which only does 10,000 RPMs, and you put in these feeds and speeds on a brand new sharp bit, you might get some okay results, but it's going to be overworking and overloading your bit. It's going to overheat your bit. It's going to, over time, weaken and dull your bit and cause a failure and or less than desired results from your carving, from what I understand. Keep in mind, I don't know what I'm doing. We're learning together. But based on that understanding of how things work, we're going to go over here to Millmage now and set up. I've got my first bit here. I think I got 10 or 12 that I need to set up, but we're going to set up one. We're going to set up the IDC Woodcraft 1/8" Upcut Endmill. And you can scan, he's got a UPC, or what do you call those things? I always forget them because I don't like them. It's got the barcode there. It's not a barcode, but you got a code there that you can scan and get details for it. But we've got it on the website, so we don't need to scan anything. But this is the 1/8" Upcut Endmill. So let's go over to Millmage and set this up. So first thing I need to do is I need to come over here and select my edit tools. And I'm going to scroll down here, and there's my 1/8" Upcut Endmill. And so I'm going to bring that up there so I don't see none of the others. I've got that where it's, in fact, I could even zoom in if I wanted to and get that to come in real nice and big so everybody can see that real good. Where is it? It's at the very bottom. 1/8" Upcut Endmill. All right. But I want you to look right here before we go. I've already looked down through here, and this is 22,000 RPMs as a desired setting spindle speed for these results. And spindle speed and chip load chip load. This is a crucial piece of information when it comes to your bits. Chip load is it's really how hard you're working your bit. And if you get an excessive chip load, then you're overworking your bit. So, since this is the specs for 22,000 RPMs and I can only do 20,000 RPMs, I need to calculate what that percentage is and then use that percentage initially across the board on my other settings, but that's not the absolute end result. Once we're done, then we need to go back and check and make sure that if we use that across the board, does it keep our chip load within that same window? If not, then we will have to make some other changes. So let's get back over here now. So I need to set up a new tool. So to set up a new tool, let's see here. Let's cancel this. Get back in here. All right, edit tools. I have nothing in here at all. So the first thing I need to do is set up a folder to put it in. So new category, and this is going to be Endmills. So Endmills. All right, there's a folder for my Endmills. I can select that, and now I have the opportunity to create a new tool in the selected category. And when I do, it populates some of this information automatically, but we're going to edit this. It comes up, it's got geometry, and it autofills Endmill. I'm going to change, no, I'm sorry, that is the Endmill. I'm going to change this right here, the name. I'm going to input the name. It's going to be 1/8 of an inch upcut. Got to move my cursor so I can see. Upcut. And I'm not going to label it Endmill because that's what it is. So 1/8 inch upcut. And the vendor, this is IDC Woodcraft. Tool number. Now, there is no tool number, at least not that I see from him. And I'm not going to number it for me right now. I'm guessing if you had, I don't think, maybe it does, I don't know. If you have some of the fancy machines that does the auto switch out, auto change, that's where something like this would possibly come into play, or, and which is something I'm going to do because I'm going to have so many bits. I don't have one right here to show you, but I got a nice little box here that I'm going to make to organize my bits in. So I'll put a raised floor with the 1/8 inch holes for my bits to be organized and engrave and label them. And then I can number them 1, 2, 3, 4, 5, 6, 7, 8. And so then when I'm doing a job and I pull up and say I'm assigning this tool to this path, so okay, I need tool number 3. Now I go, okay, 3. So it's just helping me organize it. That's the way I'm going to be using that field. Right now, I'm going to leave it blank. Now, it's asking me for my diameter. And here, it's telling me 3 millimeters. I think that's just the default. But if I come over here and I look at the shank diameter, he's got a 0.125 inch or 1/8 inch. Well, this is in millimeters because that's how I have my my machine preference set up. Well, I don't need to worry about inches or millimeters right here. He's telling me that my shank diameter is 0.125. I'm going to put in 0.125, and then I'm going to say inches, using the quotation mark for inches. 0.125 inches, and enter. And it will automatically do the conversion for you of 3.175 millimeters. I'm going to come down here to the flute length, get rid of what's in there, and I'm going to look. He has a 0.75 inch or 3/4 inch flute length. So I can come over here and say 0.75 inches, the quotation mark, or the quote, and it'll convert it. There's my flute length of 0.19050. Number of flutes is 2. Number of flutes is 2. Corner radius. There's no mention of a quarter radius, and that might be something you might see with V-bits. I don't know. I'm still learning. I'm still figuring this out. So there is no mention in IDC's website about anything about a corner radius. So I'm going to leave that value blank. Quarter radius 0. Then display units I'm leaving on automatic. Feed rate. Now, let's go ahead and we see over here he's got a suggested spindle speed of 22, or for these settings 22,000 RPMs. But I can only do 20,000 RPMs. So I'm going to set my spindle speed right here. I'm going to go ahead and say 20,000 because that's as fast as my machine can go. Then I'm going to come back up here to my feed rate. Now, his settings are set up. So far, all we've done is physical dimensions, the size and length of the tool, the cutting flutes, and all of that. Those are not speed dependent. They are a fixed value. The rest of these are, the values are depending, the speed of the spindle is going to vary these other settings. So let's figure out, since we can only do 20,000 RPMs and he's got it set at 22,000, what percentage is that? Well, that's easy. Let me get over here. We'll open up the calculator. 20,000 divided by 22,000, and it's 91%. All right, I'm going to go with 90, just 90% of the value. That's the number I'm going to use for this tool for my setup. So if I've got 90% is I can do 20,000, which is about 91%. We're going to go round it down to 90. Then all of these others, I'm going to use 90% of this value and then check my chip load and see how I'm looking. So 90%. So now I got to do two, because I'm using metric, and his information here that I'm looking at currently is in imperial. I've got to convert to metric, and then I need to calculate 90% of that and input that value into my tool. This information is crucial that you get it set up correctly to prevent damaging your bits, damaging your machine, breaking bits, efficient cuts, clean cuts. So this kind of stuff, it's going to take some time to set up. But you got to set it up once. You set it up once and save it, and you're going to be okay. And especially if you go with the IDC Woodcraft bits, because he's got a guarantee, if you break it, he'll replace it. So you're not going to have to, if you start buying stuff from Amazon and it's made out of this material or made out of that material, this got this coating, this got that coating, all of that's going to change. If you're buying random bits from random locations, your feed and speeds are not going to be the same. So I recommend getting you, bite the bullet. These are not cheap, but they are quality. And if you set them up right, you take your time and you're not making any obvious cockpit errors, but let's face it, we're going to do that. And if we do that, and we do break it, he's got his guarantee. If you break it, he'll replace it. Now, if you're breaking them every other day, he's going to say, red flag, flag on the field. We got to talk about what you're doing and resolve what your issue is. But if it breaks under normal wear and tear, and even by accident once, maybe twice, I'm guessing he's probably going to take care of you. He seems like a really nice dude. So, but I would recommend spending the money, set it up in your tool library one time, and being consistent with your end mills. Okay? So, back to the setup. We know that we now need to set up all of these other values at 90% of his recommended feed and speeds and passes and all that good stuff. So, let's go do this math, this 4-letter word. All right, so I'm going back up here to our feed rate. He's got a feed rate of 50 inches per minute. So get my calculator back out. And 50 inches per minute, 50 inches, and 1 inch is 25.4 millimeters. Now that is the easiest conversion you ever, for U.S. folks, for everybody here in the United States, or anybody using the US dollar, this is the easiest conversion you'll ever have to commit to memory. 1 inch equals 25.4 millimeters. 25.4 millimeters equals 1 inch. $1 has 25 cents 4 times. 1 inch equals 25.4. $1 equals 25 cents 4 times. Get it? 25.4, 1 inch. That's how I remembered it decades ago, and I've never, that conversion rate has never escaped me. So 25.4 millimeters equals 1 inch. 25 quarters times 4 equals $1. 25.4, 25.4, 25.4. All right, so we've got 50 inches per minute. So 50 inches times, I don't even know if I hit times, we're going to clear it out. So 50 inches times 25.4. That's 1,270 millimeters per minute. But I can only do 90% of that, I think, right now. We're going to have to look at that. So we got 1,270 times 0.9, or 90%. So 1,143 millimeters per minute. That's what I'm going to put in here. 1143. Then I need to come down here and look at my plunge rate. And I can just leave this open because I've got that up here out the way so I can see everything. So he's got a feed rate of 50 inches per minute with a plunge rate of 25 inches per minute, which is half. So he's plunging, or feed rate is how fast your spindle is moving around the path to do its job. Plunge rate is how fast is it going to insert into the material. Now he's got it plunging at half the speed that it's cutting and carving. So we've already calculated what it's 1143, and half of that now is going to be our plunge rate. So 1143, I've already got that number there. We'll just say divided by 2 equals. So I'm just going to say 570. So my plunge rate is 500 and I got yep, I messed up. I fat fingered my feed. So 570, and my feed is 1143. 1143. There we go. There we go. Some of y'all might have caught me mess that up, but I seen it. All right, so 1143 is my feed rate. 570 is my plunge rate. My ramp feed. Now, ramp feed. What is ramp feed? Ramp feed, the way I understand it, is when I'm putting my bit into my material, when I'm plunging it, instead of just plunging it straight down into the material to start cutting, I'm coming down, I've got hit my 0 point on my Z-axis, then it's going to start ramping down. It's not just going to plunge in, it ramps down, and then at an angle. And we got to set up our ramp angle. We got to set up our ramp speed. So he talks about our plunge rate, but he doesn't talk about our ramp speed. And if he's comfortable with a plunge rate of that just plunging straight down at 25 millimeters a minute, doing the ramp speed at the same should not be a problem, because the reason you're doing a ramp is to put less pressure on the bit. So if just coming straight down is okay at 570 millimeters a minute, then doing a ramp, a gradual insertion, should be even better. So I'm going to do my ramp feed at 570 as well. Then ramp angle, I'm doing it at 22.5 degrees. That's the default. I'm going to leave it at that. I already set my spindle speed at 20,000 because that's the max that I can do with my spindle. My depth per pass over here, he's calling it step down. So how every time it completes a pass and it goes to step down, how much can it step down? He's got it at 0.125, or 1/8 of an inch. So I'm going to come back over here to my depth per pass and tell it, come on there, highlight the whole thing. All right, he's got 0.125 inches, and put in my quotation mark for inches, and it'll convert it. So now I'm doing a depth per pass of 3.175 millimeters per pass. step over. All right, for you laser users, step over you need to think about is kind of like LPI, lines per inch. When you're using the laser beam, if you tell it to 25 lines per inch, well, it's going to step over and make a line. Well, you're not going to get a solid field engraving that way with a little bitty point size of a 0.08 millimeter. And if you're stepping it over and only doing 25 lines per inch, well, there's 25 lines within that 1 inch area, and that stepper motor is stepping over whatever value it needs to, so you get 25 lines only in an inch. Well, step over in CNC is going to be different, and I'm going to show you a graphic here in just a second that's really cool in this software. But your bit is only 1/8 of an inch bit, and how far can you move or step over between each cut? How far can you move if you're cutting out and cutting out? Well, each time it completes a pass. If you're doing an offset or was it vector? I think it's vector. But we'll talk about that too. But every time it completes a pass and it needs to start a new row or a new line, how far is it going to step over before it starts again? If you step over too far, then you get these little ridges between your cuts. Just like with a laser, if you step over too far, you get unengraved areas. Well, unburned areas. Same thing here. If you step over too far, you leave material. So this is our step over with this bit. And with this bit, he's saying a 0.05 inch step over. So if I come back over here, highlight everything and say 0.05 quotation for inch, that's a 0.127 millimeter. 0.127 millimeter. Or some places and some folks will tell you to do a percentage on your step over. And you could come in here and tell it, I want to do a 50% step over, and it'll calculate what that actual distance is. But here we were doing a 40% step over, or 0.127 inches. Now, we filled all those fields in. But is it right? Because we had to do 90% of the RPM of the spindle, we had to do the backwards math to figure out our feeds and speeds, but we didn't check our chip load. And that's what we need to do now. Here in Millmage, as you're putting in all this information, right here, you cannot edit this field because it's doing the calculations for you. It's telling you if you do this feed rate at these speeds and this is your chip load. You're putting in a 0.02857 millimeter per tooth chip load. Now, over here, he's got a chip load of a 0.0011 inch. Well, we need to calculate what that is. So a 0.0011 times, what's our conversion? 25.4. So his chip load is a 0.02794. We have a 0.02857. So our chip load right now is higher than his recommended chip load. So we can do one of two things I can think of right now to adjust for that. We can reduce our step over, or we can slow it down. Let's look at both and see what happens, because I'm pretty sure either will work, and either one's going to affect the overall time of the carving of the job, because if you slow it down it's going to take longer. And if you take out less material per pass, it's going to take longer. So either one's going to increase our work time. But right now we want to make sure we're not overworking our tool. So first, the easiest one to check is let's just go in here and slow it down and take a look and see what it does. So right now we got a 0.02857 at 1143. let's change this to 1100 even. 1100, and that brought it to a 0.0275, and he's 0.0279. So here at 1100 millimeters a minute, we only lost 43 millimeters a minute, or about 2 inches a minute, give or take. I think that's right. So didn't lose a whole lot there, but let's bump that up to 1120. That's a 0.028, and he's 0.0297. And to be safe, let's just say 1100. We'll leave it there. Because there at 0.0275, we are just under his. But now let's go back actually and look and see. Put it back to 1143. And now you can see we're over our chip load. But let's reduce our step over to 35%. Okay, no, that did not change our chip load. So we can stay at 40%. I just learned. We're learning. Changing our step over doesn't change our chip load. I would have thought that it did, since we're stepping over less, taking less material off, but I guess it's still biting. That leading edge is still biting the same amount of area. It's just not as wide. So I guess that don't affect the chip load. So we can't change our step over and reduce our chip load. We can reduce our feed rate or increase our spindle speed, and we don't have the option to increase our spindle speed. So slowing it down seems to be the only answer right here. I learned something. All right, so now check it again. Chip load is a 0.0011. He's got a 0.027, and we'll round that to a 0.0278. And I've got a 0.027. You know what? And actually, I need to put that back to 1100. 1100. There we go. And now I'm a 0.0275. He's at 0.0279. Yeah. All right. So that should work with this end mill. Now that I've got all that set up, I'm going to move this over here and show you something. Move this over. Oh, it didn't give me what I thought it would do. All right. Apply changes. There it is. There's what I was looking for. It gives you an illustration of what your end mill profile looks like. And it's showing you this is your total flute length from the top of your flute to the bottom of your bit. It's showing your overall diameter of your end mill. And here, and it's hard to see on this, each one of these is a millimeter, give or take. But you can see all of the measurements of your end mill. So it kind of helps you visualize whenever you're looking as, okay, well, I'm going to step over half of its diameter. Okay, well, I'm going to be taking, I can see that. What is half? I like it. And especially once you start getting in here and we start setting up some V-bits. And because right now the end mill is pretty cut and dry. It's just a straight cylinder that cuts. Your V-bits, however, they're coming to a point. And why is that? How is that different? Well, with that coming to a point, say if it's an 1/8 of an inch and it's a 20-degree 1/8 of an inch V-bit, well, it comes to a very fine point. If you come up 1 millimeter, well, not it's so wide. If you come up 3 millimeters, it's even wider. So being able to see when you're taking your plunge depth down on your V-bit, the further you plunge, the wider your cut's going to get. So if you want to keep a real fine, detailed line, well, then okay. Well, I know I don't need to go cutting too, because if you go, you can't go any wider, of course, than the thickness or the width of your end mill. So if you've got a 3 millimeter end mill or an 1/8 inch end mill, the widest that cut's going to be is an 1/8 of an inch. But if you only wanted an 1/8 of an inch, then you would need to know by looking at that profile on this bit that how far. You don't want to go any further than this, you know. So, all right. So that's setting up. Let's go back over here. and say OK. So now let's make this full screen. Full screen. There we go. If I was to come in here and set up a path, and then I'm going to assign it an operation. I'm going to say this needs to be, in fact, I'm going to carve this whole thing out as a pocket, which you wouldn't want to do with this bit. But let's say I was going to. I'm going to tell it I want a pocket here. I need to select my tool. I'm going to select this tool. Why? Because it's the only tool I have set up right now. So I've got that tool set up, and I can say OK. Now I come over here and I set up what my instructions are for this pass, for this pocket. So my starting depth, because I'm going to set my z-axis 0 at 0. The final depth, I want it to be, we'll say 6 millimeters. There's my depth per pass. My ramp, what type of ramp do I want it to be? Do I want it to zigzag in or plunge? I'm going to go with plunge. So it will just go straight down but at a ramp. Oh, no, wait a minute. Oh. Number 2, I just learned another thing. Entry type. You can do a zigzag ramp, or you can do a plunge. So when I've got zigzag ramp turned on, it's going to ramp in at a 25-degree angle. But if I do a plunge, it just straight down and plunge. And we set that up with its plunge rate, so we're good. Step over. Let's see, feeds and speeds, ramp feed, spindle speed, plunge rate, chip load. We don't have our step over. Was that the default? We'll go back and check that. In fact, let's see, select tool. Yeah, it's there. That was its default, 0.127. So okay. So that's its step over. You could change it here if you wanted to. I don't know why you would, because we've got the optimum settings in there. So yeah, it was 40% step over, 1.27 millimeters. We're doing a total 6 millimeter pocket with the maximum depth per pass of 3.17. We did a plunge entry. Here's our type of clearing pattern. Do you want to do an offset pattern like this, or do you want to do a raster, not vector? Raster. Raster is going to make it go back and forth, back and forth, back and forth, and then a final cleaning cut. And your outline pass can be before or after or no outline. Now, me personally, I want mine after. So I'm going to do my raster cut, all the movement, and then once it's cleared out that pocket, go back and do a final cleaning cut. And I'm still got to figure this one out. This one I'm not sure about in Millmage. If you know, put it down in the comments. Let me know. Help me out. This is cut direction, and it's asking me if I want to cut on a climb or on a conventional. Now, I don't quite understand this. This is a Upcut Endmill. Cut on the climb or cut on the conventional. I'm looking at the images here. Conventional. I don't understand that one. I'll have to do some more research, and like I said, if you know, put it in the comments. I'm going to leave that at conventional. Raster angle is 0. Now this would be like your scan angle on your laser. If you wanted to scan at an odd angle at 22 degrees or at 90 degrees or whatever, you can change the angle in which your machine will work. Now, I think your raster angle of 0 is going to be your most efficient, because there you're moving on the x-axis back and forth, so you're not having to move but one direction. If you change that to a 90 and now you're still moving in one direction, but depending on your setup, you might be well, that's still only going to be moving the base. I'm looking at the Cubiko. The base, the y-axis, the actual base moves. The x-axis, the spindle moves. You're moving less mass and less material moving on the x-axis with the Cubiko. So I'm going to stay with the 0 degree on my raster clearing. So raster, doing an outline after. Conventional raster angle 0, an amount of stock to leave. I have seen this, and there it says amount of material to leave behind, allowing for a final cleanup pass. So if simply because I would, if I knew that this was my roughing the end bit, I'm not going to tell it to go to the final depth to begin with. So if I wanted a 6-inch pocket and this is my rough end cut, I'm going to probably tell it to go 5.5 millimeters. But that's what this stock to leave would be. It's like, okay, well, you want a 6 millimeter pocket and you're roughing it in, so leave an extra 0.5 mil. So it's just going to back it off a bit. Then you can go back in when you switch out your bits to your final bit and engraving for cleaning to get that really fine, smooth finish. Like maybe you're doing a ball end mill or something, and just going to give you a much better finish pass. All right, so there's what I know, and it's limited. I'm learning, but that's setting up your first tool in Millmage. Now I need to go set up a whole bunch more and do all the calculations and get ready to do my first project with my IDC Woodcraft end mills. Yay! I'm silly, I know. I'm Steve, Hobo with Wood Chips, and thank you for watching. And if you can contribute with any knowledge that you see, wait a minute, you said that wrong. My ego is not too large for this internet. I welcome the feedback, because I am learning and I'm trying to share with those who want to learn. We'll learn together. And if I make a mistake, don't worry about stepping on my toes. I admit I don't know what I'm doing, but we'll figure it out together. Thanks for watching, and I'll see you in the next video.